Before I leave this topic altogether, I'd like to discuss, though, where an imperfect square root would be on a number line, if we could see it. We know that the square root of 4 is equal to 2. And if we did a 2 squared, we would be back to 4. So we can use what we know about our square roots in order to figure out something that's close to the square root of 13. We're trying to get a lower one and a higher one as near to the square root of 13 as possible. So 2 times 2 is 4. 3 squared would be 9. 4 squared would be 16. I have my answers right here. I have the 2 that I would need. If I took the square root of 9 and the square root of 16, I would allow the square root of 13 to be between them. So I know that the square root of 9 is less than the square root of 13, which is less than the square root of 16. I can simplify the perfect squares. 3 is less than. I can also simplify the square root of 16 because that's a perfect square. These are both rational numbers. So I know that the square root of 13 is somewhere between the 3 and the 4 on a number line. Since I can't give you a value for the square root of 13, I would have to leave it like that. But it gives me some idea of where it would land within a number line. Because there are rational and irrational numbers peppered throughout all of these. The whole numbers, or the actual 1.5s or the 7.5s that we did before, the 7.5 actually clearly is on the ruler, but there's lots and lots of divisions between the numbers themselves that house these irrational numbers. So here's an example. Let's say we were trying to figure out the square root of 23 and where that would fall on our ruler. Let's try to get on either side of it. 5 squared gives us 25. So here's what we already know. We would have the square root of 16 in this case, and the square root of 25. We know that square root of 16 is less than the square root of 23, which is less than the square root of 25. These are perfect squares, so we can express them as rational numbers. 4, 5. We know that that comes right here on our number line. So the square root of 23 is somewhere between the 4 and the 5. So this can just be copied since we cannot simplify it easily. But the square root of 23 is actually closer to the square root of 25 in that the number is closer. It's farther away from 16. Here we have 16, 17, 18, 19, 20, 21, 22, 23, 24. See how it's actually closer, the 23 is closer to the 25 than it is all the way over here to the 16. These are the numbers that we're thinking about. So on the number line, if we had a 4 on the ruler, the square root of the square root of 23 would probably be a little closer to the 5 than it is the 4.